everyone. Thank you so much for taking your time to come to this panel and listen to our individual presentations. We really appreciate it. So today I'm going to be talking about a few case studies on resilience planning through smart infrastructure and digitalization. So we've heard many speakers talk about digitalization from an industrial point of view. I'm going to be talking about it more from a municipal and heavy civil infrastructure point of view, i.e. stormwater. So let me tell you a little bit about, there we go. Let me tell you a little bit about Storm Sensor. Storm Sensor is a company that empowers leaders to create resilient communities by providing actionable insights, linking critical infrastructure and climate intelligence data. We work with cities across the US to track how water moves through storm, sewer, and coastal systems, and we map that movement to climate and weather data. So the best way to think about this is if you look at your phone, you were driving somewhere, you have your Google Maps, and you see it gets red or orange and green, and it changes over time. We want to provide that same insight to cities about their stormwater infrastructure, so they know where they're having blockages, where it's most likely to flood. That data just currently doesn't exist, and that's what we're helping provide cities today. So, flooding costs the US $32 billion a year. Has anyone here ever been impacted by urban flooding? Okay, we've got a few hands. So Florida obviously is an epicenter. We've got lots of lakes and rivers and the coastal communities, sea level rise, lots of these factors, not to mention that a lot of our infrastructure is aging. It was built decades ago for smaller communities with less roads, less impervious surfaces. For example, 50% of the flooding that happens in the US happens outside of a FEMA flood map. Most people that live sometimes don't even know that they're in a FEMA zone just because the maps are not available to them. And the American Society of Civil Engineers has rated America's stormwater infrastructure as a level D, or grade D rather. And so there's lots of improvements that need to be made for us to be more resilient when it comes to flooding. So we created 3 different products that we feel like have helped communities, and I'm gonna go over 3 case studies. Oops. No? Okay, and I'm gonna go over 3 case studies and how these 3 products help. So the first one is called Surfer, Stormwater Urban Flood Risk. It's a, you know what, we're just gonna go with it. So Surfer is Stormwater Urban Flood Risk. It's a map-based index that allows you to see your city in different regions. So you could see it by parcel, by grid, however you would like, and you can see where your flooding will most likely happen. So it gives you a little bit more information than FEMA does. And we will be talking about Neptune Beach, which is a community on the Atlantic coastline right around Jacksonville area. Terrapin is our real-time data. So that's something that's really important because it allows cities to react and prioritize. So we're going to be talking about the New Jersey Transit System and how they use Terrapin to respond, i.e. evacuate, hundreds of millions of dollars of assets to avoid flood damage. And the last example will be cloudburst. So these are the reports that take that 5-minute interval data that they get over multiple days and compile it through data analysis into reports and how they can make actionable insights to make better decisions for capital improvement projects. So Neptune Beach, what were their issues? They had coastal and urban flooding, they had no data on their stormwater and limited funding. So they used Surfer, and what did they get out of it? They determined the why of their flooding, and they were able to prioritize their flood risk and prepare for $20 million of grant funding to address this. So a lot of the times in order to get grant funding, these cities need the data to demonstrate the need for the funding. So let's go over what Surfer is. So Surfer uses 8 physical and 16 social vulnerability factors to draw the map. And the way that looks like is if you look at FEMA basically just shows you elevation. So you see the areas that are red versus green, and then if you look on the other side, you see that Surfer, it prioritizes different regions. So if you compare that, you see that there's different indexes based on what Surfer found and what FEMA found. And then you can see that Surfer decided in our data analysis, why is this keeping on going? Sorry. So here you can see, for example, the areas that are red. Why did it receive a red? It was due to low elevation near surface water, and the social factor was unemployment, under 17, multi-unit home, low income, et cetera, versus the area that's yellow has a different region based on all of those factors. So next example, New Jersey Transit. So they needed real-time data to be able to not have their improvement infrastructure be wasted. So they used Terrapin, the real-time data, to determine when they need to respond and evacuate hundreds of millions of dollars of assets. And so what does Terrapin provide? So you see a graph, you get data from sensors, local weather and tides, custom analytics, and you can respond in real time. And so this is what the customer would see. They would see precipitation and depth. And the last example is Norfolk. It's also a coastal environment, also very urban. And so they compiled all the data, and they found that a lot of their stormwater actually had tidal intrusion. So that's something they did not anticipate, and that's something that the data provided for them. So they were able to take that knowledge from their data analysis to make better capital improvement plans later. And so this is kind of what I was talking about earlier with using different amounts of data to see where is flooding most likely to happen. And you're able to see that tailwater impacted their stormwater infrastructure more so than they anticipated. And these are just some of the interesting facts, the insights that they gained from this real-time data. So 18 of the 26 monitoring points were impacted. 1.3 miles is how far inland their stormwater was impacted by tides. 70.7% of the records indicated diminished capacity due to that tidal intrusion, and 32.8% of the records indicated that the tailwater was going back into the system. And yeah, that's it. Thank you so much.